A very warm welcome to all of the students who are viewing this lecture on concept of programming using C. Basically, the aim of this course is to teach you how to solve problems using a computer. And by the end of this course, we will hope that you can write museum-sized programs, maybe running onto a couple of hundred lines of code comfortably in the C programming language. Programming nowadays is considered a basic skill similar to mathematics that is needed across all disciplines like engineering, in the sciences, and nowadays even in the arts. So a little bit of programming skill is an enhancement to any other skill set that you might already you have. This course we will start from the ground up. We do not assume any prior experience in programming, whether in C or any other language set. Now we can see the process of programming. So a couple of words about the process of programming. It involves two basic steps. One is to define the problem. Often you get real world problems which are not precise enough to write a program. So the first step would be to define and model the problem. And this is a very important step in large scale software development. However, we will not focus on this part as a part of this course. During this course, you will not write large software system like the Indian Railways reservation system. Those are extremely complex problems involving multiple programmers. In this course, we will assume that the problem is well defined and already provided to you. So they will be precise and they will be fairly short and simple to understand. So this is the first step of programming, which is definition of the problem which you can assume which is given below. Now comes the second step, which is to obtain the logical solutions to your problem. So, and what do you mean by a logical solution? A logical solution is a finite sequence of steps. Do this first, do this next. If a certain condition is to do this, otherwise do something else. This is called an algorithm. So an algorithm is basically a finite step-by-step procedure to solve a problem. One way to visualize an algorithm is using a flowchart. If you are new to programming, it is recommended that you draw flowcharts to define the solution to your problem. Now, algorithm in real life. Any step-by-step guide, example, assembly instructions for a make it yourself kit. Another way you can be familiar with algorithms is when you have the or when you buy a make it yourself kit for a furniture or something like that, and you will be provided with a step-by-step instructions on how to assemble the kit. Often when you buy disassembled table or something like that, it will come with a sheet telling you how to start with the component and build a table. Those are also similar to an algorithms which you provide you a step of instructions to assemble the following kit or product you have provided. Flowcharts to depict an algorithm. So let us look at a flowchart to depict a mathematical algorithms, and we will use this flowchart to explain certain conventions about how algorithms can be described. So every flowchart will have a start and an end, and it will have a finite number of boxes. So this is a finite number of instructions that I was talking about. There are certain conventions in drawing flowcharts. The start and the end are often described in circles. So here we can see that start is described or given in circle, and end of the block of the flowchart is also a round shaped circle. Then there are ordinary boxes and there are diamonds. We will shortly describe what they mean. So suppose you want to write an algorithm for adding the first n numbers. All you have to do it. The point is, how do you describe this step by step to somebody who does not know it already? So first you have to take what is the upper limit n, and then you have to sum up them. So one way to sum them up is start with an initial sum equal to 0 and then add numbers one by one. So increment a counter from 1 all the way up to n. So you start with I equal to 1 and then add the ith number to the sum and then increment I. If I is already n, then you are done. If I is already n, then you are done. If I is not n, then you go back and do all the sums again and again until you hit an I of the. When you reach I equal to n, you come out of the program, print the sum, and end the program. So this is a very simple flowchart. So initially, if n is less than 1, you have nothing to do. If n is greater than 1, you start a counter from I equal to 1 to n and add the numbers one by one until you hit the nth number. If you wanted to compute a slightly different or another problem, which is, let us say, the factorial of any number, which is just a product of the first n numbers, the flowchart will look fairly similar as given here. The only difference is that instead of adding numbers, you will multiply them. So this is flowchart is similar to the previous flowchart. You will first input n numbers and then increment n until you hit n equal to m. If you will finally print the factorial, otherwise you go back to the loop. So here are the conventions used. The start symbol is often as a circle or an oval. The input symbol and the output symbols are often represented as parallelograms. These are the parallelogram boxes, open boxes. And the normal operation boxes are represented as rectangle. Normal operational boxes are represented as rectangles. These are the input and these are the output. These are shown by the parallelograms. And the test box to see whether you have hit a limit to test some condition is general box. They are represented as diamond. Where your condition is checked if m is equal to n. So these are the diamond boxes which are shown here. So here we can see the flow chart to calculate the n factorial of numbers. Here we can see that notations m, f, n are called variables. They store one number at a time. So it calculates the factorial of any number. Like if 5 is input as a number, then it will calculate the factorial of number, that is 5 into 4 into 3 into 2 into 1, which is equal to 120. Now the programming cycle. So once we understood what are algorithms, we will start writing a few simple programs in the C programming language. Before we begin, we will give a brief introduction to the process of the programming or how the programming is to be done. When you are programming, you follow typically what is known as the programming cycle, and this contains three parts. One is the process where you write and edit of your program, and after you are done editing the program, you save it and then you can compile your program. If your compilation succeeds, you are ready to run the program. If your compilation fails, then you are returned to the editing step and correct the errors and compile again. Once compilation process succeeds, then you can run the program and check whether the output is correct, and if the output is correct, you are done. If not, you can back to the editing of the process. Here we can see that the programming cycle, write your program or edit, that is change or modify your program. So here writing a program, then compiling it with a program, and compilation errors. If there is any type of error, then you go back to writing and editing part and compile it again. And then if there is no any type of compilation error, then we run the program, and if it is correct, then we are done. Otherwise, if it is not correct, then we follow the remaining process again and again. So this is why it is known as the edit, compile and run cycle. So you edit the program first, then compile it, and if there are compilation errors, you go back and edit it again. Otherwise, you run the program. When you run the program, if the logic is correct, then you are done, and if your logic is incorrect, then you go back and make changes to this program, compile it and run it again. So this is the process that we have to follow in the when we program. We look at each steps one by one. Now we can see the editing. In editing, it is typically done in what is known as any type of editor. And now editor is a program that lets you create a text file, make changes to the text file and update the text file. Later save it. So in order to create a program, pick a particular editor of your choice. If you are on Linux, I would recommend a simple editor like gedit, and if you are on Windows, then there is a free editor called Notepad++, or you can simply use the Notepad. Be careful that this is not the usual Notepad that comes along with the system. You have to download the Notepad++. Write code in editor of your choice and save it into a file. So this can be done like that. Once your code is saved, you have to compile a program. Now, why do we have to compile a program? Why is this step necessary? The computer does not understand C per se. It cannot execute a C program or the individual statement in a C language correctly. For example, let us say that in C you write G equal to A modulus or percentage B. The percentage operation stands for modulo. So this statement says that you take A modulo B and assign it to the variable G. Now the processor in the computer cannot execute this statement because it do not understand this C programming language. So it translates it into an equivalent piece of code consisting of even more basic parameters. For example, A, this is just for the purpose of illustration, and it is not important that you understand exactly what is going on. But in a statement like G equal to A modulo B can be translated into a bunch of statement saying load data from particular memory location into particular register, load the second piece of data from another memory location to the second register and divide the contents of these two registers, store the remainder in a third register, and then finally take the result and store into a third memory location. Why program in high level languages like C? So why not programs in a microprocessor language or in assembly language? Writing programs in machine language is very tedious. One line in a higher programming language like C translates into multiple lines of machine language. So writing machine language code is very long and it is very tedious and is particularly prone to errors. Also, they are not portable. If you write machine code for a particular processor, let us say you are writing the code for an Intel processor and you translate it to an AMD machine, it might not work. Whereas if you take your C code and compile it in another machine, it will run on the machine. So compiler work as a bridge. What they do is take a high level C programming language and translate it into the equivalent machine code. So think of them as a translator. You So you the input in a C program and then you give it to a compiler. The output of the compiler will be equivalent machine program for whichever machine you want to run it. So compiler is a translator which translates from to a machine code. Here we can see the C program is given to a compiler for C for a given target machine. An equivalent machine instruction program on a target machine will be generated. Now, how do you compile? We just have seen why we bother with compilation and on Unix system or Linux system. You can compile the program using the GCC compiler, or in Windows you can install the Turbo C compiler for compilation of your C program. So GCC stands for GNU C compiler. So for example, if you have edited and saved your file as a sample.c, you can just type on the command prompt on the terminal gcc sample.c. This one is written here. If your code does not have any errors, then the system will silently say that the compilation is done and it will show you the prompt. If there are errors, the system will list the errors, and so you go back to the editor, edit your code to correct errors and come back and compile again. As long as there are compilation errors, there will be no executable file is created. So the executable file is the code, is the file that you finally run. This is an executable file, and if there is a compilation error, the compiler will not produce any executable file code. Now let us look a very simple program in C. Open your editor depending on which system you are in. So let us write a very simple program. It is a very short. What it has is are the 3 lines of code and some punctuations. This is known as the C syntax. Let us examine this code. What this code does, it prints in a particular message which is welcome to C. Now if we compile and run this program, now compile the program, system compiles without errors. In Turbo C compiler, if you compile a program and if there is no any type of error, then it will give create a executable file of this program. Compilation create the executable file a.out by default and now run the program. So screen will show the printf statement which is written in our program, that is welcome to C. So let us see various C programming statements which are we have written in our program. These are has include studio.h. What are its components? It had 3 lines. The first line said has include studio.h. So it has multiple components. One is the first symbol, which is has the first symbol which is hash. Please do not forget to include that, and actually there is no space between the has and the first I, so there is no space here in has include studio.h. This line is supposed to tell the compiler that please include the standard input output library. The standard input output library is what has the print routines which will print output message on the terminal. So if you want to have any input output component of your program, then you should include include studio.h, that is standard input output header file. Include this line routinely in your program in the first line of your C file, because in the course of this class we will often need scanf and printf statements. So if we will often need input statement and output statement, so include this by default. Now if you look at the second line, we will have a function called main. We have a function called main, and again note the parenthesis here, that is also a part of the syntax. These are the parentheses, and so main is supposed to be a function All C programs start by executing the main function, and it start from the first statement of the main function. Here we can also see the main function here. Now, what does the main function have? What does it? So it has a single line which says printf welcome to C. This is a printf welcome to C. So printf is a function called to output for a C program. Printf provide output to a C program. So to print a particular message, you enclose it in double quotes. Here we have to enclose our message welcome to C in double quotes. Please note the extra punctuation symbols which tell you that these are valid C statements. So all the underlined symbols are important. So in the line printf welcome to C, this is what is known as a C statement in C, and statement in C and with a semicolon. So this semicolon is also important because it tells you that this is where the statement ends. What typical errors do we have when we code in C? So what type of errors will generate in our program after successful compilation of it, or if it not successfully compiled? Let us systematically enumerate a few common errors that could happen in even a simple program like what we have seen. For example, you could forget to include stdio.h. If you do not include the standard input library, then the compiler will give you an error message. For you may forget to include the main function. Then also you will get some error message. Forgetting semicolon. You can forget to include the semicolon in a statement. You could forget to include the braces or brackets, the curly braces in the main, or forget to choose the double quote, open or close the double quote in the printf statement. So there are few errors that you could make even in a simple code like what we have seen. We have only 3 lines, but they could also have errors. I would advise you to try deliberately making these mistakes in your code, try compiling them and study the error messages. Once you are familiar with error messages, this will help you later in your coding, because when you see the error messages, you can guess what errors did you possibly make in your code. So go back to the code and correct it. Try deliberately making this mistake in your code, save them and try to compile. Study the error messages every time. Familiarity with error messages will help you finding code errors later. Now thanks for watching this video lecture. We can come up with more simple programming examples and other topics related to our concept of C programming. Thank you very much.